Okay, we're COMP2068, and this is week 11, lesson 11, part 1. And again, we're talking about a couple things today. One, like I said, I want to talk about your final project. But firstly, I want to go into Sprite Sheets and all that kind of stuff. However, just before we start, I want to go into a couple of options that you want to look into for yourself for your final project. Some of you may want to pursue something called Box2G Web. I kind of showed you that really briefly. So if you go to Box2G Web, right, look that up. It is the Box2D port of the Box2D Flash for JavaScript, right? That's what it is. This is what it looks like. Where you have your Box2D Web, it's a physics engine that you can use with JavaScript. It's not that well documented. So the documentation is really poor, right? But however, there's quite a few examples online, and there's some tutorials online on how to get this all going. In fact, I have a little tutorial that I put together last semester for how to do a platformer. So if I was to go to GitHub, go to my GitHub, and go to my site here, under repositories, I have something called, if I go just start typing platformer, there's a Box2D Web platformer that's done with Create.js. So you can actually download this package, and I've already done that. And if I go to downloads, as an example, let me just get rid of these VMs for a second. If I go to downloads, I have got this Box2D platformer that I've just kind of dragged from GitHub. And if I go just one in to the index.html, right, it'll run just like that. Here's my little platformer, right? So I've got my little guy, right? And let's see if I got some sound going on, right? Right? He jumps around, right? It's got a little bit of animation going on, right? If you notice the little circle around him, that's the debugger that I have got on this thing, right? So you see he's got a little bit of physics, and if he jumps, right? Hey, he's got a few states. Now, is it 100% perfect? No, I put this together like in a day, right? But so see how he's not doing his animation there. But if I change the direction he is, there's some state changes I had to fix that I didn't get around to. But the majority of it, the platforms, the way he moves and all that stuff, is a combination of using Create.js with Box2D Web, right? So you can actually create something like this, no problem. And if you notice, the frame rate's not so bad. I'm still getting 59 frames per second, right? Try running this sometimes. You get some real slowdowns. I'm running 2 canvases here, and this is how Box2D Web works. You have I have a debug canvas on the front end. That's why it looks a little weird. And you have that little bubble around them. That's the debug canvas showing up. I can turn the debug canvas off, right? So the debug canvas is on. And then on the background, I have the actual arcade canvas, which is what you see. So there's a skin on top of all of the layers. So him right now, he's actually a circle. That's the collider, right? Collision doesn't work the same as it does as we're using it in Create.js, because in Create.js, I used a kind of point-to-point collisions. Here we can't do that kind of thing. There's got to be It's a different form of collisions, because the platforms are actual rigid bodies, right, that I have to establish, that are static bodies that are not going to fall. So you kind of have to kind of create the physics for these things. I'm using a gravity of 30 pixels per meter, right? That means that because the gravity is, normal gravity is, let's say roughly 10 meters per second squared, right? And of course, in order for us to simulate that, then so 30 pixels is a meter of gravity. So it's like, so this guy's more than a meter tall. It's about let's say a meter and a bit, right? How big he is. Also, instead of making gravity regular, like 10 pixels or like 10 meters per second squared, I had to make it like 30. Sometimes 50 is better. Why? Because he'll float too much. If he can jump this high, right, he'll float way too much. So it's better off to, and again, I can choose how tall how big he jumps and everything else. All the details are in my examples. So if you download this example, it's called this Box2D platformer. This is definitely a kickoff point if you want to do some kind of platformer on your own. I don't recommend you try and do Box2D by yourself without looking at a couple of examples, and this would be one of them. Okay. Again, advantages to this platform is you get to use available physics from the Box2D engine. right? Disadvantages for this platform is development hours are, I would say, probably doubled. So please don't try and use this if you're not someone who's going to be who wants a challenge, right? This would be a bad idea, right? Because this is a challenge to make this all work, to meld it in with Create.js, to use TypeScript. And there is a TypeScript library that I'm using, a type definition library for TypeScript here. All that stuff. There's a mind meld going on here between these two libraries, and it took quite a bit of time to figure out how to do all this stuff. So if you're not someone who wants to challenge, don't do this, right? If you want a challenge though, and you really need effects, this is the way to go. It's going to give you realistic physics. It'll handle everything from rigid bodies to joints to whatever you want to do. You can make a whole a rig so it looks like the guy's actually physically walking. You can make vehicles, all kinds of stuff with Box2G Web. But again, development hours would be doubled, sometimes tripled, depending on what you're trying to do. So please don't think lightly on this kind of stuff. Okay, that's one option. And also, like I mentioned before, I'm going to probably talk about particle physics or particle systems maybe next week, just briefly. How to use them, how to incorporate them into your code, and how to write a type definition library for them, because the one that exists, there's no type definition library. So if you want to use TypeScript, you have to write one. And of course, for that one, I'm going to go to, if I go to particle physics, there's a place from Purple Monkey Studios, which I referenced before, where you can kind of create this particle emitter. It's using particleemitter.js, and what it does, you can set up this particle emitter, so you can create almost like an explosion, smoke, all this kind of realistic stuff. If you want to include this into your game, which is, I'll tell you right now, it's very common nowadays that people use particle physics for explosions and stuff as opposed to animation.
Is it a part of the assignment?
No. These are options, right? Because the reason why is animations with explosions can kind of look fake at times, right? Because they're like, it's a bunch of frames. Whereas particle physics, they look really cool, right? They look like more realistic. But again, you have to pay for it, right? Particle physics means that you gotta figure out how it works, create an emitter, and there's some stuff, there's some things around how to make this go. And again, if you want a good example of how this works, then again, I recommend that you look at something like Starbase 12, right? And I got Starbase 12 running on Heroku. It should still be running right now. So if you look at starbase12.heroku.com, right, then you'll see the game. But you can also go on, and I'll show you where the particle physics are really quickly, because I don't want to keep toting my game here, right? So it's not a big deal.
Is it actually loading, or is it just an animation?
It's actually loading. I've created a loader, right? So it basically loads all the files, and I created a little loader bar that does that. All right, so again, just really quickly play. So if you notice, I'm still getting about 60 frames per second here on Heroku, right? Right? So see that explosion? That's particle physics, right? So I used a particle, an emitter, in order for me to create that particle physics. And the way to do that, of course, is the way it worked for me is I used another container to contain the emitter. So each emitter is inside of a Create.js container object, and then what I do is I just get rid of the container, right? As opposed to trying to run an emitter in the game, I caused too many problems. It would keep emitting forever, and it slowed down my frame rate to like 3. So because there's a lot of particles, right? And there's some other things. Also, one thing to note with particles is the more colors you include in the particles, the lower the frame rate. There's just too many things. There's too much. The more, remember, because you're using JavaScript here, right? We're not using a real, it's online, right? So it's all around your browser and how good it is and all that kind of stuff. So again, I'm going to probably cover more of this physics stuff and the particle emitter stuff over the next couple weeks as little extensions or add-ons. We'll do probably like half an hour of an example, and then we're done. Like that'll be it for the training for those 2 days for week 12 and 13. Mostly week 12 and 13, like I mentioned before, are work weeks where we kind of get together and I try and help you out, or you just use these times for development hours to develop your project for your final. Right on, 8th of April showcase. That's great. Okay, so that's really it in a nutshell. Any questions around that stuff? Okay, so I want to do I want to use, let's go back to, I'm going to go on the Windows side for a second, and I'm going to launch, what do I got going? Oh, I got my MongoDB database running. Okay, let's say I want to launch my Visual Studio here, and under Visual Studio, I have this COMP2068 mail pilot demo that we've been working on from last week. And if you remember where we left off, I'm just going to use this as a jumping off point to show you how to do Sprite Sheets, right? We'll talk about that today. So here's my mail pilot, and it's got some really ugly text, right? As you can see. Let's get rid of this. So when I play the game, right, I got this, blah, blah, and some ugly text up here too. And if you notice the code for this, I'm just going to kind of close this down. And if I go to my Solution Explorer here, and if I look at the code, I have states, objects. These are two libraries of things, right? But inside of my main game.ts file, I'm just going to reduce this thing for a second. And if I scroll down, and I'll kill this, just so we have more room. I'll unpin this, right? If you look at there, I have a manifest, and what I'm doing with my manifest is I'm loading everything here in my manifest, but I'm actually accessing my HTML stuff over and over again. So I've got different files, and I'm accessing it. But it would be better if I could load everything in one big sheet. In order for me to do that, and also if I want to do any animation, the right thing to do is use Sprite Sheets to do the animation, right? So in order for me to do that with you, I need to show you how to do the Sprite Sheet thing. So one of the things we're going to be talking about today is this. And the other one is this web fonts, and that's the second part. Web fonts and bitmap fonts we're going to talk about as well. Okay, so without further ado, let's get into Sprite Sheets. So what the hell are Sprite Sheets anyway? Well, remember, I've got a bunch of little, I'm going to go in my downloads here. In my mail pile, I've kind of extracted a bunch of, and I'm going to kill some of these to start over, because I've kind of demonstrated this already one time, but we'll just kill these two. My atlas. Actually, you know what? I'll make, just in case we can't get this going today, because this all takes a long time, so I'm going to be time limited. I'm going to put in something called previous, just so that way we can always look at our previous assets, just in case I want to. And I'm just going to drop in my atlas that I generated this week, as well as my font atlas, which took a million years to make. And we're going to see how, when we do it together here, you're going to be watching paint peel while I create your font atlas for you. Right? It's really that long. But anyways, I got these items. I've got like my cloud, my PNG file, my island. I've also got my ocean GIF, my plane, my play button, all these kind of things that I want to add in, and my try again button. But I want to make these so that I only use one. Well, this is a great opportunity for us to use Texture Packer, right? So, because I want to create one sheet that I have all my stuff on. And if you look online, let's go online for a second. Now, if I go Sprite Sheet, right? If I just look at Sprite Sheet online, right? Here they are, right? Now we'll grab a Sprite Sheet randomly, and I got a Sprite Sheet. This is a walk cycle. Here's a good example of a walk cycle, and some idle states like this. Actually, there's this character here that they've got, girl with sunglasses here. If you notice, she's got, what's that? There you go. So you've got like she's walking. This is the walk cycle, and then she stops, and then she's got what looks like an idle state from here, from this point here to about here. So there's a bunch of frames here that she's got to write on. This is an easy one to fix because here's the thing. Doesn't it look like they're each proportional and it's in columns and rows? So you can certainly split this up and make it into your own walk cycle for your character. This is a good one, right? And some of them aren't as nice as this one. They're irregularly sized. And here's an example of some that are, well, this is still pretty regular. There's a chunk missing from here, but again, you can see that there's a different states. There's looks like a run state, run right, run left. There's a look up state, some kind of a look up and a look up to the left, look up to the right. Maybe he's doing something.
While running.
You know. There's also this one. You know, there's many different ones you can look at, and all they do is we're doing frame flipping, right? When we do animations, all we're doing is we're going from one frame. We're in a different sequence. We're running the sequence, and we're showing only one of these frames for our object at a time. Simple page flipping animation, right? We don't have to worry. We're not artists. We don't have to worry about stretch and squash. We don't have to worry about any of those other things that are high-end kind of animation concepts. For us, if you notice, there's the level where she's walking, and you see how her head bobs down and comes back up. That's the stretch and squash. That's her walk cycle as she kind of walks. We don't walk. We just don't walk in a straight line like soldiers. We kind of bob up and down when we walk, right?
Are there
So
free resources that you can use as a Sprite Sheet when you're actually like making an application or a website?
for real, like for real to sell?
Yeah.
No. You gotta have a good artist to do the development for you. If you want to make your own resources and everything else, there's nothing that'll do this for you. You have to kind of develop this. A lot of people, what they do, I know a lot of people lately, they develop a 3D character. This is very interesting. And something like Blender, right? They create a rig for the 3D character in Blender. They do some animation in Blender, and they capture it as a movie, and they export it as a sprite sheet. So now you get the lighting, you get all that stuff. So even if you're not an artist, you look like a superhero because it looks like you know what you're doing. Now, it may not be perfect animation, but it's way better than what you could draw on your own, right? So some people import things like meshes. They might have their favorite character they want to import, and then they do a tutorial with Blender or something like that, or Maya, and they do kind of an animation, as an example, in 3D, but they only do it from a 2D point of view, a 2D perspective, right? So the camera, the lighting, and everything is good. You got all the lighting and the sound and whatever that you've got going on, and you've done your walk cycle, and at the same time, you make the background, you can create a background almost like a flat plane that's white or black or some other weird color like yellow or green, and what you're doing is you just take these characters out and create them in a sprite sheet, and they already have all your lighting and your shading and everything else is built in. And that's what people do a lot. It looks really awesome for your characters, and you don't have to actually use a real artist necessarily, as long as you understand how to rig a character up in Blender. So a lot of people do that kind of stuff, especially from a placeholder image perspective. It's not a bad thing to do. But for our purposes, we're not going to sell our game. It's okay for you to grab some resources here on the web. There are some areas where you can get some free sprite sheets and free resources on the web, that are kind of like on a limited license where you can, and I was down last week. I tried this thing. I went to, if I go to HTML5 games, typically what I like to go to is OpenGameArtorg. Last week it was down. Let's see if it's up today. Yeah, it's up today. And on OpenGameArtorg, there are quite a few things like sprite sheets that artists make. Here's an explosion set, right? You can download. I'm just going to get to it in a second. And I'm just going to click on one of them. And it's hard for you to see this one. But basically, it's a sprite sheet that shows different kinds of explosions, right? So it's one big sprite sheet, and there's different explosions. And all you're doing, again, is you're page flipping. So you're going from here, there's the big explosion, then you kind of fade the explosion away, right? So there's lots of stuff that people do that are kind of pro bono. And all you need to do with OpenGameArtorg is kind of reference the artist and say, hey, I used his art, right? That's all they want you to do, right? And sometimes it's a good thing to give them props, like send them a note saying, hey, FYI, I made a game for class, and I'm interested in selling it, and I'm going to use your artwork. Is that okay? And usually they're good with it, right? So this is definitely a good repository of artwork to use, and I highly recommend it. Again, last week it was kind of down, so because it is a site for developers by developers, it's not something that you pay for. So then there's no guaranteed uptime, right? Okay, so we want to do the sprite sheet thing. So how do I put this stuff together? Well, I have in my downloads, I have my, I'm just going to kind of close this up for my Box2D. I do have my mail pilot, and I'm going to bring up Texture Packer. So I don't know if you guys are following along, and if you have Texture Packer, fantastic. If you don't, highly recommend that you get it. There is a cost to it. There is a free trial, I believe it's 30 days or something like that, or 15 days, that you can use. But basically it allows you to export your sprite sheets when you create them to different formats. Cocos 2D, Unity if you're a Unity guy, SpriteKit if you want to use Swift with iOS. Although probably if I was going to do something on iOS these days, I would definitely do it with Unity or Unreal. It's just better, right? But that's just me. There's different toolkits you can certainly use, and they export for these different formats. Now, Easel.js has its own format, and it's JSON, so JavaScript object notation. So let's go into Easel.js. We're going to create that, and I'm going to kind of create my project. And if you notice, I have this drag and drop area for my sprites, right? So I'm going to kind of go into my, on my, and I'm using the Mac version, but the Mac and the PC version are almost identical. So I'm going to drop in a couple things. I want to drop in my cloud. So here's my cloud, right? And if you notice, I'm just going to drag and drop here. Here's my island, right? So there's one sheet now that's going to have both things. And I'm going to drop in my plane, right? Because these are the things I want in there. I also want to put in my play button and my try again button. So those are my things that I want to put in. And if you notice what a texture packer does is it tries to put everything in this kind of mode. Now if I want things to be square, which sometimes the computer can handle a little better, right? I have to use power of 2 mode. And actually there is I can force squared, right? So it's going to be in a square. But you see there's a bit of a space that I've got in here, like a space left over. That's okay, right? So again, sometimes it's better for us to make it a square, and it's easier for later on from a performance perspective for us to read this. If you notice, the size of my square is 322 by 322. It says that this on the bottom right here, right? 322 by 322, with the size of 405 kilobytes, right? So that's the entire map. Now, here's something I don't recommend you include in your sprite sheets. It's a bad thing. I wouldn't include my ocean. It's rather large. Let me show you why, right? If I include my ocean along with this thing, right? Here's my ocean GIF, right? Now, let's try and go back to this. I'm just going to zoom out. Here's my ocean. And then here's my sprite sheets. And look at how my sprite sheet just grew to 8 meg.
Yeah.
8 meg, right?
But
So it's
the
way
GIF isn't
big.
that big.
It is quite big. It's 3 screens large, right?
Yeah, but no, size-wise.
Oh yeah, size-wise, it's this big, buddy, right? Because the ocean, this is the plane. It's down here, and I've got 3 screens. 1, 2, 3 screens. This is not one that I recommend that you install. It should be on its own, right? So I'm just going to remove the ocean by just pressing that and delete. That's the right size. Your sprite sheet should be sheets that include smaller sections. If it's a background image or something like that, I don't recommend you include it in a sprite sheet with the rest of your assets. It's just too big. Load it on its own. It warrants a load of its own if it's its own thing, right? You don't want it bogged down like that. So here's my little sprite sheet. I've got a few images here that I want to use. And now the great thing about this is I want to export this thing, right? But remember what a sprite sheet is. It's a grouping of images that are related to what I want to load. And how do I access them? I use a map or some kind of way of knowing the coordinates and the width and height of each of my objects and where they appear on the sprite sheet, and then looking at those coordinates to load that piece of the sprite sheet when I'm utilizing my object. So when I have my plane object, I'm only going to look at this part of the sprite sheet. I'm not going to look at these other parts of the sprite sheet. Sprite sheets are very common. It's a very common way of preloading your assets and incorporating them into one file so that there's less access, less requests and responses from the server, right? Where you want to improve your efficiency. And also from a page flipping perspective, you definitely don't want to load multiple files to do animations. That's just silly, right? You want to do one file and you want to move across the file, inside the image, a copy of the file that's inside your memory, as opposed to loading multiple files and skipping files. That just takes too long. It's less efficient. Okay, so this is my sprite sheet. I'm going to export it now. I'm going to click the Publish Sprite Sheet button. And when I do that, it's going to ask me for a location. I'm just going to put it in the same spot. So I'm going to put it right here. And I'm going to call my main sprite sheet, it's going to be called Atlas, right? And I'm going to save it here, right? And it's also going to ask me for my ping. So one is the JSON file. It's going to be 2 files. One, the descriptor, the JSON file, the map, if you will. And 2, the actual ping image, right? So here's my Atlas, right? So I'm going to save that too. So it exports everything properly and press OK. I'm going to keep this open. Yeah, I'll show it to you in a second. File. I'm going to also save my project just so we can get back to it if I need to. I'm just going to call this Atlas. Right, so I can get back to the actual project itself, because this is the file for Texture Packer. Okay, cool. So I've got my files now, and if you notice, I generated these 2 files: this JSON file and this ping file. Okay, I need this ping file. I don't need this JSON file the way it is, because I'm not going to read from the file. Right, I'm going to use the JSON file inside my code. How do I do that? And what is this? How do I load sprite sheets, and what are sprite sheets from a Create.js perspective anyway? Well, to know that, you have to go to the API documentation. Again, if I go to easel.js, and if I look at the API documentation for easel, and if I want to look at something like sprite sheets, I'm just going to scroll down here until I see sprite sheet. And it's a sprite sheet class. Again, if you look at it, it extends the event dispatcher class, and it's defined in Sprite Sheet 41. If I actually click on one of these things, it'll actually take me to the code for the sprite sheet itself. This is actually, the API documentation itself. You can see how the sprite sheet, if you want to build your own sprite sheet class, it shows you how to do it right here, right? And this is what I consider a well-documented API, right? This is good, right? This is not like Box2G Web, where it has nothing, right? So here, let's take a look at this now. So I've got my sprite sheet format, and it shows me I'm going to have a JSON, some kind of object is what I need. And one of them is this images property that the object must have. That's going to specify what the image is called and where the path is to the image. So the image would be for us atlas.ping, because we just created that, right? It's going to specify frames. And the frames are all going to be, you can specify a height, width, a frame count, a registration point, regx and regY for the frames built in, right? Also the spacing between the frames and margins. You can specify all that stuff, but typically it's written like this. You'll see an array, and the array is going to be an array of data points, right? The array of data points would be, for example, the x and y coordinates and the width and the height of the object. So what x and y coordinates are there in the atlas, in the spread atlas we're creating? I'd like to call it a texture atlas. That's the common name for it. If you look at, if you work with ActionScript, if you're working with Cocos 2D or whatever, a lot of times, or even Phaser, they call them texture atlases, right? Because that's what it is. It's an atlas or a map of where your textures are in the sprite sheet. So you typically see it like this in frames, and then what you have is down here is a list of animations, quote unquote, that specify which of these frames are being used. This is frame 1. This would be the 0th frame, and this would be the first frame. So if you notice, it's an array of arrays, or rather a jagged array, if you will, an array of arrays, and it's part of this object that we have to pass into the sprite sheet call, right? So I have animations. That's the next property of my object, and as an example, it says my sit animation is frame 7. So it would be, if this was frame 0 and frame 1, there'd be a few more frames down here, and one of them would be frame 7, which would actually be the picture of the person sitting, right? You can have multiple frames, though. For example, the run cycle can go from frame 0 to frame 8, right? That's how the animations work. Or the jump cycle, you can define that as frame 9 to frame 12, right? And then you want to run. So it's jump. After that, you do the run cycle, and then the frame rate, the speed is 2 frames per second. You can make it as fast or slow. You can decide on the frame rate. You can do all kinds of stuff. You could also pare it down to make it look like this. I've got my walk animation with these are the frames, and if you notice, it goes frame 1, frame 2, frame 3, frame 3, frame 2, frame 1. So you can actually specify the same frame over and over again to give it a bit of a delay and to specify your animation rate. Here's my shoot animation, where it's broken out a little bit more. I have my shoot property, which is a property of the animation property, right? A little object within an object, if you will. And inside the shoot property, I have 3 properties: frames, next, and speed. Actually, this is a shoot object. And my frames is frame 1, frame 4, frame 5, frame 6. So when I shoot, I do 1, 4, 5, and 6 when I'm shooting, right? Whatever those frames are. And then my next animation is going to be my walk animation, which is going to be this. And my speed of the animation is 0.5, which means if my frame rate is 60 frames per second, this animation happens at 30 frames per second. Yes?
I don't know how to properly ask this, but if you were to switch between walk and shoot, would it have a seamless switch between the two? Like you wouldn't see flipping on the frames?
No.
So if
It's too fast for your eye to see, put it that way.
yeah.
It would, all you're doing is page flipping, right? Because that's typically how classic animation is done, right? But what's happening is happening so fast. If anything greater than around 12 to 16 frames per second is enough that it can fool your eye. chances are you want to go to 24 frames per second for seamless animation, because most Disney animation is done between 24 and 30 frames per second now. So if you look at a Disney film, 24 to 30. Beyond that, our persistence of vision fails. We cannot see frame rates higher than around 30 frames per second. We just can't. Can't tell the difference between 30 and 60. There's no difference.
So we won't see the difference if our walking frame is with the right or shoot frame.
And unless your animations are mucked up. Like for example, if your animation for running is like this, it's kind of the characters kind of poised this way, and then you're moving to this, right? From here to this, if there's no transition. If you haven't put all the transition frames, there's going to be you're going to notice a difference because it's going to flash into that thing, right?
Yeah.
However, and you sometimes see it if you play games where you can kind of make the guy go like this, and he kind of goes back and forth from his idle state into a shoot state, right? So that's where you want to be careful. It's part of it is it's what you tell the computer's going to do what you're going to tell it to do, right? So if you want to make it smooth animation, you have to make transition states where you can move from, and that's one thing they don't mention here, where you move from shooting to walking, right? If you do a shooting, if you notice there's the next one that says walk, right? Or if you're going from an idle state to a shooting state, sometimes they include the idle state first before you shoot. So you're walking, you go idle, and then you shoot, right? Because the idle state's the transition state between the two states. Anyways, so again, you can also specify the frame rate. Instead of saying speed is 0.5, I can create a property that says my frame rate is 20. So I can specify. So instead of you calculating what the frame rate is, if you have 60 frames per second for your whole game, and you want to say 20 frames per second for this particular animation, you can do that.
With all that too, like a frame rate set as a constant of 20, can we put that in our constant variables?
You could, but I don't recommend it because in here, when you're working you're creating an object, and you'll see how this looks. And this is when you create objects like this, right? Trying to reference a variable as opposed to an actual hard-coded value may or may not work within this context. So, okay, and this is what it would look like. So here's an example of a sprite sheet. You have your data, it's called data, and here's your big object. This object here that you're defining here as data, and if you notice we're using literal notation for defining the object with properties of its own, this is going to be the thing that this sprite sheet, CreateJS sprite sheet is looking for. It needs an object. You just can't just pass in, the ping image. It's not enough. The ping image, and then there's frames and animations and all this kind of stuff. Even if you don't have animations, it's called animations. Each frame that you're showing, even if the plane has no animations, it's just a plane. It doesn't do anything. That's one frame. It's called an animation, right? So it's built in for animations, to do animations. So if I want to do a explosion animation, what am I going to do? I might have 5 frames of the explosion, or 10 frames for the explosion, right? I'll leave that in the frame section. So the frame section is going to be up here somewhere, right? And you're going to see how that breaks out. And then what I'll say is, my explosion in my animations, I might have something called explosion, and my explosion is going to be frames 1 to 5 or 1 to 10. And when I call upon the explosion animation, as you'll see, as I call upon any other one of those options, it's going to start that animation. It's going to play that animation till the end. But here's the trick. It'll repeat it over and over again until you switch states. So if you play the animation, you've got to time it properly. You've got to make sure that it only plays each of the frames until it's done, and then you switch back to your other state. Otherwise, it's going to keep playing it over and over again. Like bang. It's going to be one of these. Bang, open, close, open, close. You see your animation repeating. If it's too fast, if you make the frame rate, for example, if you have 10 frames in your animation and your frame rate's 60, how many times is it going to play your animation in a second?
6 times.
6 times. It's going to play that animation 6 times because it's trying 6 times per second. So before you get to it, so you have to slow it down. So you have to specify the frame rate is going to be 10. Right?
You can also do this. Like let's just say I want an explosion and I have an animation for that, and I want that explosion to be bigger. Can I have the same thing go up side?
Oh,
side
yeah.
by side, like 3 places?
Oh, yeah.
Like 3 explosions.
Sure. You can do all kinds of stuff, but it's just programming, right? It's going to take effort to do all that. So again, I'm just specifying this stuff because I have my animations. If you want to look at examples of this, and we're going to look at that today when we make our sprite sheets. I'm not going to show you how to do an animation because I don't have time. Yeah.
Another question with sprite sheets. Would you be able to set up level areas in the sprite sheet?
That would again be like the sky, right?
You could, but again, it's a background. right? So big backgrounds, bad idea for sprite sheets. You want to do it so that the sprite sheets are made up of, instead of a level area, you want to make it so that you may want to think about doing a tiled background. So instead of having a sprite sheet with just one big pre-done build, what you want to do is have these tiles, and in runtime, when you load up everything, you build your tile map by using the same tiles, repeating the same tiles over and over again across the map. And you can use, there's different ways of doing that. I said one of the tools I like to use when I do tile maps is tiled. If I just type tiled, there's a tiled map editor. I kind of showed you guys this before. This is kind of the de facto tile map editor that you can use. And what you do is it generates something called a TMX file. And what you need to find out how to do is, how do I load a TMX file with Create.js? Because you load that TMX file, or you can actually copy and paste the TMX file into Create.js, and then from there, that'll be your level. And what you're doing is you're accessing already preloaded resources. So you have a bunch of tiles. Let's say you have a grouping of 10 tiles that make up the background to your level, and you're accessing these 10 tiles, but you're actually reusing these tiles over and over again, for different pieces of your level. Like for example, in this background here, see how there's this green square? Well, that's a tile that's being reused a bunch of times, right? Why I don't have to make this same tile over and over again. Here's a couple of tiles, this one and this one, right? That seem to be the same. These two tiles you can probably are very close to. Maybe this one and this one are the same, right? Here's these two tiles that are the same, and this one's a little different. This corner tile and this corner tile here. So you can actually use these tiles by configuring a map with using tiled to create a background. But you don't have, the whole tile map loaded into a sprite sheet. You have these little tiles in the sprite sheet, right? That are loaded individual. They're individual files, right, for these tiles.
So it creates a map every time you load it?
What you do is you have your tile set. You have your tile set, and every level you'll just use different pieces of your tiles to reconfigure your level. So it's more efficient than loading a big tile map, a big map of whatever you're doing, right? And especially that in tiled, you can create different layers. So you can have a collision layer. You can do all kinds of stuff. Some people just use the front end for what it looks like. You can make it so that, of course, right now you're looking at square tiles, but there's nothing that can stop you from using other kinds of tile shapes. Diamond tiles, hexagonal tiles, right? There's all kinds of ways you can do it. Okay, we're getting a little bit off topic now. So sprite sheets need this form. They need this data file, right? This data object, if you will, and this is the format that we're going to use. This is the syntax we're going to create our sprite sheet. Okay, so let's see what we got from our texture packer. So if you look at texture packer, I got this JSON file. I'm going to open this JSON file up here in Sublime Text, right? And here it is. Take a look. This is what I need, right? So I've got my images, right? My atlas.ping. I know this is incorrect though, because my atlas.ping is going to be in an images folder, right? So it's got to be, my new path should be something like assets/images/atlas.ping. That's what it should be, right? I got something called frames, and if you notice, I've got these bunch of frames. One of them is, it starts at 2, X and Y locations, and it's 226 by 178. That sounds like my cloud. And if you look down here in my animations, I've got a cloud object, which is frame 0, which is this frame right here. Okay, here's my island object, which is frame 1, and if you notice, it's at 23069. That's X and Y coordinates. It is 62 by 63 high and wide, or width and height. Sorry, and it's called island. This is the moniker for it. This is the name for this frame. Now remember, these animations, right? It's called animations, but actually what they are is just images for now, because there are no additional animations. So I have cloud, island, plane, a plane button, and my try again button are all sprites. Now I have this other piece right here, which kind of creates a smart hash, if you will, or gives some credit to texture packer. I don't need that right now, so I'm going to kind of take that out. It doesn't hurt to have it in, by the way, but I'm going to take it out. Okay, so now I have my JSON file. I have all of these things, and I have this extra comma here. Is this good for a JSON file? No. This comma's got to go away, because if you notice, it's a list of objects. This is the first object, right, which is, and this is all in key value pairs. If you know JSON, it's in key value pairs. So here's my key images, and here's my value, which is an array array of image locations, and right now it only has one object inside the array, right? And here's my frames. I have a frames property or object, and I have an array of arrays that contains all my frames. And then I have an animations property, and I have it's an actual an object, a little sub-object that has other properties that are listed inside of it. All right, so this is all good JSON now. I know this is cool, so I can copy this whole thing. Let's do that. Copy this whole thing. And go back to my code here, and I'm going to create a new variable. So let's do that. Right, create a new variable, and I'm going to call it Atlas, just like it's called. Right, and you know what? Maybe image atlas would be okay for now. I'll call it image atlas, right? Or image data. That might be the right thing to do because that's what it is, image data. And then I want to assign it as this. So here it is. I'm just dragging it. Look at it. I just copied and pasted right from Texture Packer. It's perfectly good. And all I've done is created a global image data object that I can use. Okay, cool.
So it just basically does PS.
I use my Texture Packer. Now I need to include my atlas.ping file inside of my assets because otherwise it doesn't know where to look for this stuff. So in my assets, here's my assets. In my images, I'm going to put this atlas, and I might as well put both files. So I'm going to kind of grab this JSON file and this ping file, and I'm going to drag and drop it into my images folder. Okay, here it is. So I need those two things. Now, the objects that I'm getting out of my Sprite Sheet are going to be sprites. I'm using bitmaps. This is a problem, and we're going to fix all this. All right, so here's my asset loader. I don't just need my asset loader. In here, I'm going to create a new object. I want to call it Texture Atlas, and it's going to be underneath my asset loader up here where I have my game variables. I'm going to call this thing var texture atlas, right? Which is going to be of type createjs.SpriteSheet. So I need that type. That's what I'm going to use up here. So I'm going to go down here to Texture Atlas, and I'm going to say Texture Atlas then, right, is equal to, right, a new createjs.SpriteSheet. Here's my Sprite Sheet, and I want to pass into it this image data that I've defined up here. So here's my image data. I want to pass this into my new Sprite Sheet. That's all I'm doing. Okay, so once I've done that, once I've passed in my Sprite Sheet, now I can use that instead of using my asset loader stuff. Instead of doing all this, instead of using my regular manifest here, right, which I've done, I can use my Sprite Sheet instead, right? Okay, cool. So how do I do that? And by the way, let's take a look at my objects. This is a problem, right? Because my objects, if I look at them for a second, inside of my scripts, if I look at my island, right? Here's my island. What does it extend? It extends game object. That's cool, right? I'm going to change my island first, right? And what's game object anyway? Game object is a type of bitmap. So ain't going to work. Sprites, bitmaps, they don't work together. You can't use a sprite sheet to define a bitmap. You can use a sprite sheet to define a sprite. And for us to know what that is, let's go and take a look at the API documentation for Sprite. So I'm going to go back to easel.js, and if I scroll down, I see Sprite as the Sprite class. And if you notice, the Sprite class now is of type display object. It extends the display object class, and it does something like this. My instance, whatever it's called, is a new create.js sprite, not a bitmap, right? And if you notice, it uses the sprite sheet. This is an example of this. But the constructor doesn't just do this. If you look at this constructor, it says, I need a sprite sheet, comma, and whatever the frame or animation I want. So in other words, in quotations, plane, island, you know, whatever I'm putting in there, right? So that's the form. That's my constructor. That's how it looks like. Okay, cool. But I need it to be a sprite. In order for me to accept the sprite sheet, it needs to be a sprite, which means I got to change my class. So this can't work anymore, this create.js bitmap. It's got to extend create.js.sprite. And if once I do that change, it affects all objects that have inherited from it. Uh-oh, guess what? My superclass, which is a sprite, can't accept this asset loader asset string, it needs to get a sprite sheet and the name of my asset, right? So it needs to do this. So here's my sprite sheet. Guess what I called it? Texture atlas, right? Here's my texture atlas. And now, of course, I'm still going to pass in my asset string because my asset string is going to define if it's a plane, an island, an ocean, what is it? Okay, cool. So I made a change to that, right? And let's see what objects are inheriting from GameObject, because once I've done it for GameObject, all the other objects now are sprites as opposed to bitmaps, which may propose an issue later on. Let's take a look. So my cloud is of type GameObject, which is now a sprite instead of a bitmap. Does it change anything like that happens here? No. Now it's just a different type of object. It's not a bitmap anymore. It's a more complex object. It's a sprite, right? Sprites have additional properties than bitmaps. The bitmaps do not have, and they can be animated. Bitmaps cannot, not unless you use tween.js. Okay, and so it affected the cloud. The ocean also the island got affected as well. Here's my island. It's also of type GameObject. I'm still doing the same thing, right? So the island didn't get affected. Hold on, let's take a look what other things there are here. I also have a couple of other things. I have a button. Here's my button. It's of type create.js bitmap, right? If I want to make my button load, right, well then I got to make it either I change this to a sprite, or you know what? Let's make my button also a game object. Why not? I just want to include all of the objects in there. So I'm going to say objects, right, dot game object. So I'm going to change my button. Well, that means that of course this has to change because now it's not asset loader anymore. It's going to be just the string path that I need that I'm sending over. So here's my button. And you know what? I know that GameObject does this, regx and regY, so I can get rid of this in my button. So now I'm making that a button, GameObject as well. These things all stay the same though, because nothing else changed in my button. So now my button class is also of type GameObject. Why not? Let's do the same thing with my my plane, because my plane so far has been a bitmap, right? Here's my plane object, right? It's of type bitmap. I don't want to do that. I want to make it of type GameObject. So I'm going to go objects.GameObject. You notice if you see how powerful this GameObject idea is here now, everything is associated with it. I'll do the same thing with plane. I'll just pass in plane as my object, right? And the name is plane. I don't need getBounds anymore. This getBounds doesn't make any sense because I've already done this thing. This width and height is already done in my game object, so I don't need to do anything. So my plane class is going to be really slimmed down. Take a look. All this stuff is done for me now, right? Because it's all inside my game object. That's what I'm saying. So I'm saving code lines here. I'm actually reusing code, which is a good thing, right? Because my game object does all this stuff. It does width and height. It does this getBounds. It does regx and regY, and it also checks. It also has additional properties that I'm not going to use for my button and for my plane, right? But it's going to have them in place just in case I want to, because it's a big super game object or super sprite, if you will. Okay, cool. So that's what this is. So that's my plane is now a game object, and I'm going to go back to my game.ts, and to test this out, to make sure that I'm working things properly, I'm going to remove from my manifest, I'm going to remove island, cloud, plane, my buttons, try again button, and these buttons here, right? And all I'm left with my manifest is this: ocean, engine, yay, and thunder, right? So if I've done everything correctly, I'll save everything, and if I run this now, it's going to be using my sprite sheet as opposed to using my asset loader. If I've made a mistake, it's going to bite me in the ass, and I'm going to have to fix it. I'm going to refresh to make sure it's correct, and it is, right? So now I'm using my sprite sheets as opposed to my asset loader, right?
Yay.
Okay, same kind of idea.
Yay.
So does everyone understand what I did there? So again, the workflow is you use Texture Packer or another program. By the way, you can use Flash if you're really good with Flash to create your sprite sheets. You can do it by hand if you're really a stickler. If you're someone who wants to create your own objects by hand, you can throw things together. You can use something like Photoshop or Fireworks or something like that. You can throw things in together, throw things into your the bigger image, the ping image, and then from there you can map out, physically look at the object and create your mapping for it physically. So you say, well, where's my X and Y coordinate for this particular object? Well, it's this X and Y coordinate. Almost like that little spreadsheet we had before when we created our slot machine, right? See, slot machine would have been a great example of where I could have had a Sprite Sheet to hold all my stuff together, because there's all these assets. I had buttons, I had all these things, right? And I can put all that together in my slot machine, and instead of loading each individual item, I could have loaded a big Sprite Sheet of objects, because even the slot machine wasn't that big, and I could have just pointed to where the objects are, just like this, by creating an array of arrays. And as long as I adhere to the right format, which is images, frames, and animations, Create.js doesn't care, right? You can map it out on your own. Any questions around this? All right, I'll stop recording this one and we'll go to the next one.